Okay, welcome back. Starting a new chapter here that heavily relies on the fact that you still remember how to factor. So before we get started, I'm going to ask you to pause the video and see if you remember how to factor these. So go right ahead, give these a try, and come back when you're ready to see if you really do remember how to factor. So this first one, this is the difference of cubes. So if you remember the difference of cubes, it's always same, opposite, plus. We take the cube root of the first term, which is 3x, and then we square it and get 9x squared for the first term of the second set. We take the cube root of the last term, which is 2, we square it and put it in the last term, which is 4. The middle term is 3x times 2, which is 6x. That is the difference of cubes. Another thing you need to remember how to do is how to group. So we group the first two and the last two. The GCF of the first group is 3x squared, leaving us with x minus 2. The GCF of the second group is an 8, leaving us with x minus 2. So our final answer is the GCFs and the inside. Done. The next one we have is splitting the middle term, Batman, guess and check, box method, X method, whatever you choose. So 2x squared times a negative 3 is a negative 6x squared. What multiplies to a negative 6 but adds to a positive 5? That's going to be a 2x squared and a negative 3 at the ends, but those two special numbers are a 6x and a negative x. So now, just like grouping, we're going to group the first two and the last two together. GCF of the first is a 2x, leaving us with x plus 3. Factor out a negative 1, leaving us with an x plus 3. So we finish with a 2x minus 1 and an x plus 3. And the last one is the difference of two squares. X to the fourth is a perfect square, so is negative 16. So that's going to give us an x squared minus 4 and an x squared plus 4. But wait, x squared minus 4 is also a difference of two squares. So we have an x plus 2, an x minus 2, and an x squared plus 4. And being able to factor those, and of course just GCFs, regular unfoiling, the sum of cubes, all of those types of factoring that we did back in the last chapter are going to be crucial to your success in Chapter 9. So, first thing we're going to do is we're going to simplify and we're going to state any domain restrictions. So that means what can't x be is what we're going to be talking about. Okay, so how do you simplify? Well, we just got done talking about it. You got to factor. You have to know how to factor all sorts of fun stuff. So if we factor the top here, we have an x plus 4 and an x plus 1. To factor the bottom, x squared minus 16, that's an x plus 4 and an x minus 4. So, as you can see, those two terms are going to cancel out, which are going to create a whole. And we have x plus 1 over x minus 4. That is our simplified equation. So now we need to talk about the domain and state any restrictions. So, new type of notation here you need to get used to. Our domain are all values of x except x cannot equal 4 and x cannot equal a negative 4. So that's the notation you must write it in. So where did I get those two numbers? Well, all the way back at the very beginning. What's one thing that you are never allowed to divide by? You're never allowed to divide by 0. So if x was a negative 4, this would be a negative 4 plus 4, which is 0. And 0 times anything is still 0. And x minus 4, if you were to put a 4 in there, 4 minus 4 is 0. And anything times 0 is 0. So that's it. Now another way you can do it is just look at your final simplified answer. You set the denominator equal to 0, and that's how we get our x is 4, so x cannot equal 4. And then your other one is you take your whole and set that equal to 0. So your whole was x plus 4, so x plus 4 equals 0, so x is also not allowed to be negative 4. So there's a couple ways you can do it. Okay, those are two ways. Otherwise, you just look at your factored answer, and anything in the denominator cannot be 0. So number 2, again, you have to be a pro at factoring. So the first thing that you want to do in this example is you're going to need to factor out a negative. So we factor out a negative, and that's going to leave us with x squared minus 25. So that way we can see this is a difference of 2 squares over x minus 5, of course. Now we need to factor again. So that's going to leave us with negative x plus 5 and an x minus 5, the difference of 2 squares on top. And we have our x minus 5 on the bottom. So we have our x minus 5s cancel out, which again is going to create our whole. And that's going to leave us with a simplified answer of negative x plus 5. We can leave it that way, or if you really want, you can call it a negative x minus 5. So again, what is our domain restrictions here? So our domain is our values of x, except x is not allowed to be, think about it, 5. Okay, again, and that's because our denominator at the very beginning is an x minus 5, so x can't be 5 because that would leave you with a 0 in the denominator, or you can set what you canceled out. As far as wholes go, that's going to be more pertaining to graphs, but the sooner you can identify them, the better you're going to be. Okay, so that's how you simplify and state the domain restrictions, and again, that goes right back to, if you don't know how to factor, this is going to be a pretty challenging chapter for you. So if you struggled with any of those 4 in the beginning, you might want to go back and watch some of the factoring videos from chapter 6. So here's examples number 3 and 4. Of course, they are a little bit more challenging here, but that's just the way it's going to be. So what I would do if I were you is I'd pause the video and try number 3. And I'll get started and show you what you're supposed to do, and we'll see if we get it correct. Go for it. So here we go. What are we going to do here? Well, how about we start with the top. The top can be factored by grouping. So if you factor the top, you're going to factor out your x squared, and you're going to be left with an x minus 2. And then you're going to factor out a negative 9, which is going to leave you with an x minus 2. And that's going to give you x squared minus 9 and an x minus 2, which is x plus 3, x minus 3, and an x minus 2, because x squared minus 9 is a difference of 2 squares. So that is your factored form for the top. So we're going to go write that on the top. Okay, and now we'll factor the bottom. So if we factor the bottom here, the first thing you might want to do is rearrange this so it's easier to work with in descending order. And we're going to factor out a GCF of 2x. So we can factor out a 2x from everything, so that's 2x. And again, in descending order, that would leave you with an x to the 4th minus 7x squared plus 12. And of course, that can be factored some more. So what's going to multiply to a 12 and add to a negative 7? We have our 2x, we have our x squared minus 4, and an x squared minus 3. And of course, we have the difference of 2 squares for the x squared minus 4. So we have our 2x, our x plus 2, our x minus 2, and our x squared minus 3. That cannot be factored anymore, so that is our denominator. So we have our 2x, x plus 2, x minus 2, and x squared minus 3. So that is our denominator. So now what we need to do is we need to state our domain and simplify. So we're going to state our domain first for this one because we have a lot of terms, so it'll be easier to just not get confused. So our domain is x when x is not allowed to be 0, x is not allowed to be a -2 or a +2, so we can just call that plus or minus 2. And right here, x is not allowed to be plus or minus the square root of 3. So we have a lot of restrictions for this domain. And of course you state this because it is a real number. We do not need to state imaginary numbers for part of our domain, okay? So let's go back and simplify this. Let's see what we can cancel, and out of all of that mess, the only thing you can cancel are the x minus 2's. So your final simplified answer is x plus 3, x minus 3, and that is over 2x times x plus 2 times x squared minus 3. And again, you leave it factored. This is simplifying. This is not factor and then FOIL back to get a bigger, crazier fraction. So we just leave it just like that. Okay? So we need to go back up and talk about number 4. I am going to tell you to pause and see if you can take this entire thing down to the very end. So go ahead, pause the video, try it on your own. So when you factor the top on this one, you should have first factored out a -3x, which would have left you with an x cubed minus 8 on the top. And of course, that right there is the difference of cubes. So that's going to factor to a -3x, an x minus 2, and then an x squared plus 2x plus 4. Okay, so that is your top. Again, we write that in the top. And now we're going to go factor the denominator. So we're going to factor out a -x for the denominator, which is going to leave us with an x squared plus 2x plus 4. And that cannot be factored anymore, so that is your denominator. So from here, I'm going to go back and I'm going to state my domain first. So my domain, x can be anything except for 0 for this guy. And this second term, you would need to set that equal to 0 and solve using the quadratic formula or completing the square. I recommend the quadratic formula. So if you set that equal to 0, you would get -1 plus or minus I root 3. And as I said in the last example, we do not need to list imaginary numbers in a domain. So the only value that x cannot be is 0 for this example. But we still need to cancel those guys. So your final simplified answer for this problem is, and of course we can factor out our x's and our negatives. Final answer for this is 3 times x minus 2 all over 1, or you can just leave it blank. Okay, that's it. So again, you need to be a pro at factoring for this unit. This is Longo and I'm out. See you, bye.